When you were in elementary school, middle school, high school, you learned formulas for areas of a lot of plane figures. But here's one that wasn't on the list. And we're not going to determine its area right now, but we're going to estimate the area. So estimate the area. Under the curve, y equals x squared, above the x-axis, between x equals 0 and x equals 1. So I'm going to draw a picture of that. You're going to want this picture in your notes. So we know what y equals x squared looks like. It's just a parabola. We're interested in the part that goes from x equals 0 to x equals 1. Of course, that curve goes through the point 0, 0, it goes through the point 1, 1. And that's a shape. We want this area under here, the part between x equals 0 and x equals 1, underneath this curve above the x-axis. So this shape that we have no name for, underneath this curve above the x-axis between these 2 points. Now, here's how we're going to do it. We're going to take this region, and I'm going to make an arbitrary decision here. We're going to divide it up into n equals 4 parts. We're going to take this interval from 0 to 1, we could have divided it into fewer, we could have divided it into more. In this case, I'm just going to specify n equals 4 in the question. Okay, so, and we want these parts to be equal. So if we take this interval of length 1 and chop it up into 4 parts, each one's going to be a quarter unit long. So let's say we can chop it up into 2 equal parts by putting a dividing line at 1/2. We can chop it up, each of these 2 equal parts, into 2 equal parts. So we put a dividing line at 1/4, a dividing line at 3/4. And I'm going to do, on these 4 little intervals, 1, 2, 3, 4, what we call a right-hand sum. Meaning that I am going to construct little rectangles, which the first rectangle is going to go between x equals 0 and x equals 1/4, the next one between x equals 1/4 and x equals 1/2, and so on and so on. And each of these rectangles is going to touch the curve on its right-hand side. So this little one, this first one that goes between x equals 0 and x equals 1/4, it's going to touch the curve at x equals 1/4, its right-hand side. I just have this short little rectangle which touches the curve right there. The second rectangle is going to go between x equals 1/4 and x equals 1/2. The third rectangle is going to go between x equals 1/2 and x equals 3/4. And the last rectangle is going to go between x equals 3/4 and x equals 1. And we're going to take the area of those 4 rectangles and add them up. And that's going to be the estimate for the area underneath the curve. Now, if you look at our picture right now, you can see we're overestimating. The total area of the 4 rectangles is bigger than the total area under the curve, because we're including certainly all the area under the curve, but all this area above the curve too. So we are overshooting. But it's the best we have right now. we know how wide each of these rectangles is. That's a quarter unit wide, that's a quarter unit wide, that's a quarter unit wide, and that's a quarter unit wide. Let's go ahead and figure out the height of these rectangles. So that first rectangle touches the curve right there. The x-coordinate of that point is 1/4. This curve is y equals x squared. So to get the y-coordinate, all I do is take 1/4 and square it. 1/4 squared is 1/16. So that's the y-coordinate of that point. That's the height of the first rectangle. So a right-hand sum, we're going to abbreviate RHS. The first rectangle is a quarter unit wide, and its height is 1/16. Now we're going to do 3 more rectangles. The second rectangle, all these rectangles are a quarter unit wide. So the next rectangle is a quarter unit wide. See, quarter. Its height is where it touches the curve right there, the height of the curve right there. Well, the x-coordinate is 1/2. The y-coordinate, you always get the y-coordinate by plugging the x-coordinate in. What's 1/2 squared? 1/4. So the second rectangle is a quarter unit wide. It's also a quarter unit high. So pause the video and work out the width and the height of the third and the fourth rectangle. I'm assuming you did that. But that third rectangle, we know it's still a quarter unit wide because they're all a quarter unit wide. And its height, the x-coordinate of that point is 3/4. So the y-coordinate is going to be 3/4 squared, or 9/16. If you don't like fractions, I don't care, do this in decimals. And this last rectangle touches the curve at x-coordinate 1, so the y-coordinate is also 1. And it's still a quarter unit wide, they're all a quarter unit wide. And so the total area of those 4 rectangles is given by that sum. I'm going to work it out using fractions. You don't like fractions, work it out using decimals. So 1/4 times 1/16 is 1/64. That's the area of this first rectangle. The second rectangle, 1/4 times 1/4, that's 1/16. This third rectangle, 1/4 times 9/16 is 9/64. And the last one, 1/4 times 1 is 1/4. To add up fractions, I'm going to get a common denominator. 1/64 plus 4/64 plus 9/64 plus 16/64. And if we work that all out, we end up with 1 plus 4 is 5, plus 9 is 14, plus 16 is 30 over 64, which is 15 over 32. A number a little less than 1/2. So right away, we know that the area under this curve is less than 15 over 32, because we knew we overshot. Now what I want to do is a left-hand sum with 4 equal subintervals. Now I know my picture is getting crowded, but what I want is 4 rectangles which touch the curve on the left-hand side. Again, the first one's going to go between here and here, the second one between here and here, the third one between here and here, and the fourth one between here and here. That first rectangle, if it touches the curve right there, it has no height at all, because the curve is at height 0 there. So it's just a stupid looking rectangle, which is just this horizontal line right there. The second rectangle touches the curve right there. And so the second rectangle, let me draw these in a different color. So I'll put them in what I think is blue. So the first rectangle is just a flat line there. The second rectangle touches the curve at its left-hand side. The third rectangle between 1/2 and 3/4 touches the curve at 1/2. And the fourth rectangle between 3/4 and 1 touches the curve right there. So in other words, the second rectangle now is as tall as the first rectangle was in our first sum. The third rectangle is as tall as the second rectangle was. And the fourth rectangle is as tall as the third rectangle is. There are still 4 rectangles. N equals 4, there should still be 4 things in our sum. Whenever n equals 4, there should be 4 things in our sum. So let's do the left-hand sum. Like, we're going to abbreviate this LHS. So the first rectangle, its width is 1/4. The width of all these rectangles is 1/4. The height, we said, is 0 because it touches the curve at x equals 0, and the y coordinate there is 0. The second rectangle touches the curve right there at 1/4 at its left-hand side, where everything touches on the left-hand side now. We know how high that point is. It's at height 1/16. So its width is still 1/4, its height is 1/16. The third one still has width 1/4. Its height is now going to be 1/4 because it touches the curve at x equals 1/2, y equals 1/4. And the last one touches the curve, so its width is still 1/4, it touches the curve at 9/16. And so what we have here is 0 plus 1/64 plus 1/16 plus 9/64, getting a common denominator. I have 1/64 plus 4/64 plus 9/64, and this works out to 14/64, or 7/32. So one thing you can see about these blue rectangles is that they are underneath the curve. And so this time we undershot. This is an underestimate of the true area underneath the curve. So the true area underneath the curve is at most 15-30 seconds. And at least 7/32. It's somewhere between those. Usually at about this point, somebody puts up their hand. You're not here to do that, but I'm sure that the gears are turning and they say, could we get a more accurate estimate by averaging those? In this case, yes. In general, it doesn't really work that way. But in this case, absolutely. So how could we get a more accurate answer? We have some sort of answer which is better than what we started with. Well, to get a more accurate answer, I think you can see that what we could do is increase the number of subintervals that we've divided this interval into. If we divided it up into 10 parts, we would have had smaller parts above the rectangle and smaller parts left out for our left and our right-hand sum. The downside is we would have had to do more work. If we divided it up into 100 parts, we would have got a more accurate answer still. But we have to do a great deal more work.